Okay, this is 3.3 in your grade 8 Math Links textbook. These are the show you knows for the section on how to estimate non-perfect squares. So when we talk about perfect squares, we know that 25 is a perfect square because the square root of 25 can be represented by the whole number 5 multiplied by the whole number. And therefore we can say 25. So therefore the square root of 25 is 5. It's a whole number. It's 5. The square root of 100 is 10, and so on and so forth. But the ones that we have here in the examples, the square root of 18, 23, and 35, they are what we call non-perfect squares. They are irrational numbers, meaning I cannot represent them with a terminating decimal or a whole number or even a repeating decimal. So if I think about the square root of 18, if I went to my calculator and said, let's see if I get it here. The square root of 18, I hit my square root button right over here. It would tell me it's 4.2426, blah, 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 blah. And this number would never, ever, ever stop. It would go on forever, not repeating a pattern forever. So it says it's approximately 4.2. Okay? We can't say it is equal to 4.2 because we're rounding. So anytime we round, we have to say it's approximately. But if we took that exact same question, and rather than use a calculator, we're to draw a number line, and over here put a perfect square I know, and over here put a perfect square I know. And I chose these two because the square root of 18 will be between the square root of 16 and the square root of 25. So since I know the square root of 16 is 4 and the square root of 25 is 5, I know before I even use a calculator to do anything that the square root of 18 is approximately 4 decimal something. Right? But what we can do is we can kind of use its proximity to each other to kind of estimate its general value based on how close it is to the ones we do know. So the square root of 18 is 2 away from 16, and the square root of 18 is 7 away from here. So a good place to put it would probably be around here. The square root of 18 is maybe somewhere around there, right? Definitely closer to the square root of 16 than it is to the square root of 25. So therefore, we could say it's 4 decimal 2-ish or so. And if we think back to what our actual calculation was, 4 decimal 2 is pretty close. So a good estimation for the square root of 18, not using a calculator, would be 4.2. And if I took my number line for the second question for the square root of 23, the posts I'm going to use are still going to be the square root of 16 and still going to be the square root of 25. So the square root of 23 is only 2 away from 25 and again 7 away from the square root of 16. So I could put it roughly there, which if I was guessing is going to be roughly 4 decimal 8 something or other. So it's approximately equal to that. And that's estimating without a calculator. If I bring my calculator up here and go, what is the square root of 23? It tells me 4.79583, which if I round it to one decimal place would be 4 decimal 8. Good estimation. And the last one is what is the square root of 35 using a number line. So this time I got to change my posts this time because square root of 35 falls between the square root of 25 and the square root of 36, right? This has a square root of 5 and this has a square root of 6. So I know it's 5 decimal something for sure, right? I know the square root of that's going to be 5 decimal something. It's pretty darn close to 6. So I'm going to guess it's around 5 decimal 9 or maybe 5 decimal 8. But when I take my calculator and go, what's the square root of 35? What number when multiplied by itself gives you 35? It's approximately 5 decimal 9. Okay, so that's how you estimate square roots using number lines. The second question in the show you know says identify a whole number with a square root between 8 and 9. So what this really means is if I was to take a number line and put my 8 up here and my 9 up here, what square roots would fall in between there? Well, I know that this 8 is really a different way of representing the square root of 64. And this 9 is a way to represent the square root of 81. So any number that's between here, so all the way, any number between the square root of 65 all the way to the square root of 80 exactly, those are all of the whole numbers which will have a square root of 8 decimal something. Okay? That's really what it's asking you. So how many are there? Well, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, and 81. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers, 16 whole numbers, excuse me, have square roots between uh, 64 and 81, or 8 and 9, 8 decimal something. And the last one says, determine the length of the hypotenuse for the right triangle to the nearest centimeter. So for this one, I'm just going to do it the way I always do it. I like to do it this orientation here. It doesn't really matter. This leg is 6 and this leg is 10. And this leg is, I don't know. So I'm going to attach squares to all of the sides of this right triangle. I'm going to put inside each the areas. This is 36 area. This is 100 area. And since it is a right triangle, the area of this would be 136. So we have a square whose area is not a perfect square. It's 136. So if I was to use my number line, this would be the square root of 121, which is 11. The square root of 144, which is 12. So I know that that hypotenuse, or that side length, has to be 11 decimal something. 136 is 15 away from here, and it's only 8 away from here. So probably there is a good place to put the square root of 136. So I'm going to guess it's like 11 decimal 6 or 11 decimal 7. I'm going to go with 11 decimal 7 as an estimation. Take my calculator just to double check. The square root of 136 is 11 decimal 66. So 11 decimal 7 was a pretty good guess. So 6, the hypotenuse, excuse me, is exactly equal to, this is actually an important thing. So what is the length of the hypotenuse? Well, the length of the hypotenuse is exactly the square root of 136, or approximately 11 decimal 7 centimeters. This is the exact length. This is the approximate length. Okay, your first question says estimate the square root of each number to one decimal place and check with the calculator. So my estimation here, I'm going to use the square root of 64, which is 8, the square root of 81, which is 9, so 8 decimal something. It's kind of right in the middle almost, so I'm going to guess 8 decimal 5-ish. Take my calculator to check. Square root of 72 is 8 decimal 48, so 8 decimal 5 was a good estimation. For the square root of 100, I'm going to put or 103, I'm going to put the square root of 100 here, which is 10. And over here, the next perfect square would be the square root of 121, which is 11. It's pretty darn close to this, so I'm going to guess 10 decimal 1 or maybe 10 decimal 2. I'm not sure. Take the 103 and square root it. It's 10 decimal 14, which is 10 decimal 1. And finally, the square root of 155 will fall between the square root of 49, which is 7, and the square root of 64, which is 8. So I know right away the square root of 55 will be 7 decimal something. It's kind of 9 away from this and 6 away from this, so it's kind of closer, right around there maybe. So 7 decimal 4, maybe 7 decimal 3. If I take 55, I go square root, it's 7 decimal 416. So it's a good guess with 7 decimal 4. Question 6 says, what's an example of a whole number who has a square root between 9 and 10? So just like our show you know, we're going to put 9 here with a square root of 81. We're going to put 10 here with a square root of 100. And we're going to say any whole number, so the range who would have a square root of 9 decimal something would be any number from 82 all the way to 99. Any of those numbers. So if you said the square root of 93 will be between 9 and 10, you're right. I took my calculator just to check. Square root of that is 9.6, which is between 9 and 10. Question 8, identify all the possible whole numbers with a square root larger than 2 and smaller than 3. So that's just a different way of saying between 2 and 3. So if I do my number line and put 2 and 3 here, this would be the square root of 4. This would be the square root of 9. So the whole numbers that would have roots between that would be the square root of 5, square root of 6, square root of 7, and the square root of 8. Those are all numbers that would have a square root of 2 decimal something. Question number 10. Kai uses an entire can of paint on a square backdrop for the school play. The label on the can states that once a can covers 27 meters squared of wall surface, or that's what it will do, estimate the backdrop side length to 1 decimal place. So this was the backdrop. It was a perfect square, and he used the entire can, which was said to cover 27 square meters. So essentially, the side length is exactly the square root of 27. But if I'm going to estimate it, I'm going to put the square root of 25 here, and the square root of 36 here, and 27 is probably around here. So since this is 5 and this is 6, a good estimation is roughly 5.2, which means the side length was roughly 5.2 meters. If I take my calculator to be a little bit more exact, the square root of 27 is 5.196, so 5.2 was pretty darn good. Question 12, it says, while shopping online, Ji-hun finds a square rug. So I'll draw it with an area of 11 meters squared. He needs to know if it'll fit in his room that's 4 by 5. Okay? So let's check. The first thing we need to know is what is the side length, right? Because it's a square. So this time I'm not going to estimate. I'm just going to use my calculator. I'm going to say, what is the square root of 11? It's roughly 3.3 meters. So if I was to draw his room, which was 4 by 5, since it's 3.3 by 3.3, it will fit in his room. Okay? So the answer is yes, it will fit. Question 13 says, Stella is planning an outdoor wedding. She would like a square dance floor with an area of 115 meters squared. Now, I know that women like to have nice weddings and stuff, but that's pretty picky to have one request that I need for my wedding, it has outdoor wedding, I need to have a dance floor with an area of 115 meters squared. And I need to have certain types of flowers and blah, 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 blah. Men just need a bucket of chicken and that's it. That's all they need for their wedding. But anyway, Stella wants a floor that is exactly 115 meters squared. It has to be square. Can't be rectangular. It has to be square. So if it's 115 meters squared, then the side length of this square will really be the square root of 115. So if I use my calculator and I go, what is the square root of 115? I know it's probably 10 decimal something. And it's 10 decimal 7. So the side length of this dance floor will be approximately 10 decimal 7 meters in length. Stella finds out the dance floor will be made up of floorboards that measure 1 meter each. What are the two side lengths of the dance floor that can have what she wants to as close as she wants? So therefore, the closest she's going to get it will be 11 meters by 11 meters, right? And when she does that, she will have an area of 121, which would be closer than if she did a 10 by 10, which would have an area of 100, because it's only 6 meters squared off from that one, and a whole 15 meters squared smaller than she wanted. Question 15 says, order the following numbers from least to greatest. So really what I want to do is I just want to change these two numbers to decimals. Square root of 27 is going to be 5.2 or maybe 5.1. And the square root of 46 is pretty close to the square root of 49, which is 7. So I'm going to say it's probably 6.8, maybe, roughly. So that's 6.8, and that's 5.2. That's 6.8. That's 5.2. So therefore, from the least, this would be the smallest. This would be the next smallest. This would be the next smallest. This would be the next smallest. And this would be the greatest. And question 16 says, a fitness center will install a square hot tub in a 6 by 6 meter room. So here's a 6 meter by 6 meter room. They want the tub to fill no more than 75% of the room's area. What is the maximum area of the hot tub? Well, this is 36 meters squared, right? That's the area of the room. So if it's maximum of 75% of the room, that means I need to find out what is 75% of 36. So I'm going to use my calculator for this, even though I know it's 27. I'll just take my calculator and go, what's 75% of 36? And the answer is 27. So the maximum area of the hot tub is 27 meters squared. So therefore, the hot tub can be in that 36 meter squared room. can take up an area of 27 meters squared. So the last thing says, what is the maximum edge length of that? So since the square root of 27 will be just a little bit more than 5, I'm going to use my calculator, probably 5.2. So the square root of 27 is 5.2. So therefore, the greatest size hot tub they can get is a 5 by 2 by 5.2 hot tub. And the last question says, determine the two numbers that have a square root between 326 and 327. All right. So the square root of 326 and the square root of 327, we know that, sorry, that's a 2, that's 327. We know that this number here must be 326 times 326. So I'm going to put down 326 times 326 equals 106,276. And over here, 327 times 327 is 106,929. Okay, so the first thing is I got my number line, but it also has to be divisible by 100, which means the last two numbers have to end in 0. So between those ones, the only numbers that fit between those square roots are the square roots of 106, 300, the square root of 106, 400, the square root of 106, 500, the square root of 106, 600, the square root of 106, 700, and finally the square root of, no, there's two more, 106, 800, and the square root of 106, 900. And it has to be a multiple of 6. So in order to be a multiple of 6, it has to be a multiple of 2 and 3. So if I add these digits together, 1 plus 6 plus 3, that is 10. So 10 is not divisible by 3, and therefore it's not a multiple of 6. 1 plus 6 plus 4 is 11. 11 is not a multiple of 3, so it's not divisible by 6. 1 plus 6 plus 5 is 12. 12 is a multiple of 3, and it's divisible by 100, and it has a square root, so this one is one of them. 6 plus 1 plus 6 plus 1 plus 9 is 16. That is not a multiple of 6. 6 plus 6 plus 1 is 13. That is not. 6 plus 1 plus 4 is 14. 14 is not. Hopefully the last one is. 6 plus 14 plus 1 is 15. There we go. Bing bong. Those are your two numbers whose square root is between 326 and 327. It's divisible by 100 and has a multiple of 6. Now just to check, I will take my calculator to make sure. So 106,500, if I press the square root of this, it does have a square root that falls between 326 and 327, so it does work.